Hello. You should see the desktop and should hear me. Is everything seem okay? Get everything set up. Okay. So can you hear me? Is everything seem all right? Yes?
Yes.
Yeah, okay, great, thanks. Okay, so today we're going to start talking about designing classes. Okay, we're gonna today we're gonna cover these two sections here and start a little bit on this section here. And I give a reading assignment which again mentions this section here. We definitely won't finish it today, and also this other section here on classes. So today we're going to talk a little bit more about objects, immutable objects, and start talking about classes. Okay. Now, to give you an idea, what we want to do is we want to get a sense of what's inside of code like a turtle. You know, when we say that we program a turtle, we give it commands. The turtle remembers where it is, remembers what direction it's heading. We wanted to start designing our own objects like that. We want to design an object like a turtle that represents something. So far, we've been writing methods, but we haven't been writing the design of a whole object. So that's what we want to start talking about. Okay, so what I'm going to do is we're going to start talking about this distinction between. I'm going to start with this distinction between. Oh, where was it? Sorry. Oh, mutable and immutable code. Okay, there's these two chapters in a row in this book on what are called immutable objects. It's still talking about objects and mutable objects. So but this lets us start talking about what we mean by classes a little bit more by talking a little bit more detail about objects. So what I'm going to do is start an example in the Java visualizer. Okay, now we've played around a lot with strings. So here's a reminder of something about strings. If I have a string reference variable and I create a string object, okay, if I visualize that, okay, now if I visualize it now, this is actually the wrong picture. Okay, this is actually an object. It should be over here in the picture. And this should be a reference variable that points at the object. And for some reason, the Java visualizer, remember, wants to draw strings as if they were primitive variables, where the value sits inside of the variable itself. So remember, you have to go here and click this little box to get strings drawn the right way. Okay. So that line of code created a object that's a string object, and it created a string reference variable, and it pointed the reference variable at the object. Okay, so it does three things. Okay, this thing does three things: creates the object, creates the reference variable, and points the reference variable at the object. Okay, now once we have a string object, we can do things with it. We can tell it well, we could ask for what's the char at, say, 3. Okay. Now, if we ask it for the char at 3, it's going to give us back an answer. So we need something to hold the answer. So we need a variable c, a char variable, to hold the answer. Okay. Now, this is index 0, 1, 2, 3. So index 3 is the second of the two L's. Okay. And if we visualize this, we just see that we're calling a method on the string. We're calling a method on the string. Now, this is an object. What we want to remember is that objects hold data. Okay, this object holds the letters, 5 letters, H-E-L-L-O. Okay, and what we just did is we accessed one of those letters. We asked the object to tell us what is the letter in your third position. Okay. Another thing we can do is tell the object to uppercase itself. Okay. Tell the object. Now, this is where things get a little bit strange. The data in this object is H-E-L-L-O. You might think that this is telling the object to change its data to capital H, capital E, capital L, capital L, capital O, okay? But Java objects are Java strings. This is where the word immutable comes in. Strings are immutable. So this does not, Java cannot change the letters in a string. Strings, once you build a string, the data in it is frozen and the data can't be changed. That's what immutable means. There's no mutation of the data. So here, if this was a mutable string, this would change the data in the string. But Java doesn't work that way. What this does is it creates a new string, and it gives us back a reference to the new string, and we're going to store the reference in a variable. So what this does is this method makes a copy of this object. It changes the letters in the copy to be capital H, capital E, capital L, L, O, and then it gives us back a reference to the copy, which we store. Okay, and if we visualize it, oh, what did I do wrong? Oh, I forgot the capitalized case into uppercase. Now you can see that this one didn't get changed. You call to uppercase on that string, and it doesn't mutate this one. It says, okay, what I'll do is I'll make a new object. I'll fill it with a copy of my data, but with the data modified to be uppercase, and I'll give you back an arrow to that object, and then I store that arrow in another variable. Okay, here's something like, what if I didn't store the variable? Like, what if I just do this now? That compiles. Whoops. That compiles. Okay. Okay, now I'm about to do line 5. I'm about to tell this string to uppercase itself. And nothing seemed to happen. Okay. Okay, does anybody want to, how would you, if somebody asked you this, somebody like said, gave you a quiz, or if somebody was asking you, what's going on here? What happened in that line of code?
There was nowhere to store it, so we can't see it.
Right. So what actually happened to it? It got built, but do you remember what the object got created, but what happened to it?
It didn't have a reference.
It didn't have a reference. So remember, what's the word? Do you remember what word we used? When something doesn't have a reference, what happens to an object when there is no reference to it?
Garbage.
Garbage collected. Yeah, it was scooped up by something called the garbage collector, and it was deleted. So if in a sense, it existed for a split moment and then got deleted. It got created. The reference that was returned was never stored anywhere. So then the object that was created lost its, there was never an arrow pointing at it, so it disappeared. Okay, so the object was created and then it was garbage collected. Now, there are other languages where this method is a mutating method. In Java, it's not, but there are other libraries and other languages where if you have a string reference to a string object and you call to uppercase, then the object changes itself. But Java doesn't do that with strings. Java strings are immutable, so you can't change them. Okay? And similarly, I could do the same thing with two lowercase. Okay, two lowercase will give me back HELLO with a lower, yeah, there's only one letter that needs to be lowercase, but this will also, it'll create a new object. So that'll be my third string object. Okay, that's my third string object. Now, notice I only created one string object myself, and here I picked up new objects because I called methods that created objects. And this is why this idea of immutability is important. If you want to know how many, well, let me do another example. There's a fourth string reference variable. Okay, but how many string objects do I have?
3.
3 still. I mean, you have to read the code carefully to see how many objects there are. You can't count the reference variables. This has got a name. When I say that str4 equals str2, does anybody remember there's a name for doing that? I copied this arrow into that variable. So the arrow in this variable got copied into this variable. Does anybody remember what that is called?
Aliases.
Alias. Because what have I done? Why would they call it an alias?
Because you just gave the same object a different name.
Yeah, an alias means another name for something. When something has an alias, it's got more than one name. These are really names. See, these are names. They're not objects. And I keep emphasizing that. These things are reference variables. They act as names for objects. Here it's clear that I created an object and gave it a name. Here it's not so clear that I created another object. I have to understand that strings are immutable, so that this created a new object, so that gave me another object for that guy. Now I have to understand that this gave me another object for this guy, and this one's not another object. Okay. Now here's another. Okay. How many objects do I have?
Four.
Okay, there's 1, 2, 3, 4 reference variables. Do I have 4 objects? Okay, there's 4 reference variables. Do I have 4? Well, this guy is still pointing at what?
String 2.
String 2. So he doesn't represent an object. So of my 4 variables, one of them is an alias. So that means how many objects can I have at most?
3.
3, because I got 4 variables. I can only have as many objects as I have variables, because remember, objects can't exist if something's not pointing at them. They get garbage collected. I've got 4 variables. I know one of them is an alias to another one. So that means there's not that one doesn't represent a new object. So that means this one, and this one could be objects. String 2, and string 3. Okay. But now if I look over here, I say, okay, there's an object. That created an object. That created an object. And this creates another object. So I got 4 objects, but I said I can only have 3 objects. This is confusing. Okay. I've got 4 reference variables, but one of them is an alias. So that means at most I can have 3 objects. If I read the right-hand side, I see the creation of 4 objects. 1, 2, 3, 4, because this creates the object that is a string that is the substring of this guy. how many objects do I have actually? If I visualize this, how many objects am I going to see at the ends of arrows?
3.
3, but I created 4. So what happened?
Because you renamed, well, you reassigned str to the substring.
Yeah. So what happened?
str no longer refers to the original hello, it now refers to
So the original hello is
garbage collected.
garbage collected. Yes. So I created 4 objects, but I managed to lose a reference to one of them. This line of code actually made me lose a reference to one of the objects I had a reference to. The hello disappears on us. So we're left with this uppercase one, this lowercase one, and this substring one. Now let's watch. So we're going to end up with 3 objects: the uppercase one, the lowercase one, and the substring one. Oh, what did I mess up?
On line 8, you don't need to use string before the variable name.
Oh, yeah. It's already been declared. I'm sorry. Yeah, good point. That's already been declared, so it doesn't need to, I shouldn't be declaring it again. So I'm reusing a variable name, so I shouldn't declare it again. Okay, now there's one object. There's a second object. There's a third object. Now, here's the line that's going to be, well, here's the alias. So there's the 4 reference variables, but only 3 objects. Now, here's the funny line. This is going to create a new object. And this is going to make this reference variable point at the new object. It's probably going to be down here. And we'll lose a reference to this one. So the original hello goes away. Okay. Now, notice they reshuffled everything. Okay. They reshuffled everything. So the object that up here didn't mutate into this thing. If you go back, you have to realize that like this object just shifted up and this one shifted up and the new one was down here. So they shifted these 2 up. See, they shifted those 2 up and then the new one's down here at the bottom. Okay. Don't accidentally think that this object somehow changed into this object just because it's in the same place in the picture. You gotta be real careful. That's not what they mean over here. So this one got garbage collected. So they just kind of push these up in the picture and put a new object down at the bottom. Okay, so the new object is down here. Now we still only have 3 objects. Okay, and this is the substring of that one. Okay, because we took the substring of string 2, we took the substring of string 2, so we're taking the substring of this one, so we got double L's. Okay. All right. Now, immutability can make things a little bit tricky to read because when you call methods on immutable objects, quite often they give you back new objects. Okay. The data that what would have been a change to this object actually shows up as a new object. What would have been a change to this object shows up as a new object. Okay. Right. Okay. One last example here of this example. Suppose I do the following. Let's see. I'll use string 2 again. Okay. Now, notice that I'm calling a method on this string, and then I'm using that same reference variable. Okay, so I have this reference variable points at an object. I call that method on that object, but then the return, that creates a new object, but then I use this as a name for it. What does it look like I'm doing here? Does anybody think of a way to describe what this is doing?
No, I don't know. It doesn't seem like it would work because you're replacing the name.
It works because it happens in steps. So this reference variable points at an object, right? And on that object, I say call substring. So that builds a new object. So step one is follow this arrow to the object. Step two is build a new object using the arrow, the object you pointed at. Then step three is copy the arrow from the new object back to this one. Okay, now that happens after you've called this method. So that's why that's why it works when it seems like it might not. You think these might kind of somehow interfere with each other, but because they're done as steps in time, first you go to this reference variable and you follow its arrow to the object. Then you call that method on the object. The method builds a new object. You get back
Okay,
an
that makes
arrow
sense.
to that object and you store it in this variable. Okay, but by then you're done calling the method. So it's the last thing you do is you, so now what does that end up kind of looking like? Now, remember, I said that these things are immutable. So if you call this method on this string, you don't change that object. You actually create a new object, and we're storing the new object in a reference variable. Now look at this. I've got this reference variable to this object, and I call substring on it, and then I store the result back in here. Can anybody see what that kind of mimics what it seems to be doing?
Is it kind of changing itself?
Yeah, it's changing. It pretends to be mutating string 2. It seems to be changing itself, which is what, if these were mutable strings, this would, see, if this was a mutable string, this would chop off part of that string. See, if this was a mutating thing, it would say, oh, take this string and chop off the part that comes after 3. But it's not mutating. So what it does is it builds a new string. And in the new string, you've chopped off what comes out after 3. But then you use this reference variable to point to that string. It ends up looking like you mutated the string, but you didn't really. Because what happened is one string got garbage collected while one string got created. This line actually creates, this is kind of actually tricky. It creates one string and garbage collects another string. Can you read all that? It creates one string and garbage collects another string. There. Creates one string and garbage collects another string. That's way different than what would be mutating a string. So it looks like it's, now let's watch it. Okay, let's get down to that line. Okay, now string 2 points to HELLO. Okay, string 2 points to HELLO. Okay, one more step. Okay, string 2 now points to, oh, this one had that kind of messed things up because there was another arrow pointing to that string 2. I didn't want there to be another arrow, so let me do this on string 3 instead. It'll look a little bit better if I do it on string 3, because string 3 doesn't have an alias to it. So let me do it on string 3. Okay, string 3 points to HELLO, all lowercase. See, it seemed like I mutated string 3. But notice how it moved it moved its location. It moved its location because what really happened was this object got garbage collected and this object got created. Though it kind of looked like I mutated string 3. Okay. It looked like string 3 changed from lower, it looked like I was mutating the value in the string. But in fact, what I was really doing was garbage collecting the old string and building a new string that I'm going to point at. And I point at the new string. A lot of times people use a line of code like this to mimic mutation, to make it look like I changed string 3, when in fact I'm really building a new string and throwing away an old string. Okay, building one new string while I throw away an old string. And we'll see as we go on, that's very different than actually mutating. Now, strings are immutable, so you're never allowed to modify what's in a string. So if you really want some string to just change, like if you just want a string to be replaced by its uppercase, like I can go back up here and we'll see what we. Just create a new example. I have a string S, and it is okay. Now suppose I want that to be in lowercase. I can just say S equals S dot to lowercase. Okay. Now that's how people would mimic mutation. But it's not really mutation because it's really throwing away the original string and replacing it with a new string. And from the point of view of the computer, that's a lot more work than actually just mutating the string, because mutating the string would just need to change this letter here. Yeah, if I was really mutating the string, I would change that one letter and I would change that one letter. But in fact, what I'm doing is building a whole new string that's that length, copying all the data from this string into the new string, but changing capital H to lowercase h and changing capital T to lowercase t. Then I'm throwing away the old string and keeping a reference to the new string. Okay, but when people write a line of code like 12, they write it quite often to create the impression that you're mutating that string. See how it looked like mutation? Because it was at the bottom of the picture, it didn't need to be shuffled around. So it looked a lot like I mutated it. Now that can fool people. Yeah, if you're not really careful about understanding the language, you could be fooled into thinking that that was a mutation, that you took that string and converted it to that string. When in fact, what you really did is you took that string, made a copy of it, threw that string away, and replaced it with a copy. Okay, so that's what Java means by immutable, and what some of the ways you should think about things that are immutable. In modern programming, more and more objects are being treated as immutable. Java had a good reason to make strings immutable like this. And there actually is a mutable string that's got a different name. If you want a mutable string, yeah. Oh, this is, I'm trying to build something called a string builder object, but this is a string object. So I have to say new string builder. This is Java's mutable string. Okay, now notice that the Java visualizer even draws it completely different. It doesn't even show us what's inside of the string builder, which is really kind of disappointing. That it shows us what's inside the strings. It doesn't even show us what's inside the string builder. So it's kind of hard to show you that it's actually mutable. Yeah, but unfortunately, the way the Java visualizer works, if you do things to the string builder, I can't remember what's the, see if I remember, string builder dot. I don't remember if it has a substring method. Probably. Okay, but now I have no way of knowing if something changed in there. So I have to print it. Now notice I didn't do this. So if I called this method on this object, now I want to see if it mutated it. If it returned a different object, I would have lost the different object, and this thing would be unchanged. So let me print out what's inside SB. See? And it didn't mutate it. Okay? Yeah. So the substring method on a string builder still didn't do mutation. Huh. I forgot what, so this one actually did return another object. So so even the string builder, which is a mutable string, some things in it mutate and some things in it don't mutate. Okay, like this one turned out not to mutate that object. Okay, I'm trying to remember which one would mutate it. There's a mention of them in here. Let me see if it tells. Or is it in here? Here it is, string builder. Let's see, which method actually mutates a string builder? See if you find one real quick. Oops. Okay, I think that'll actually mutate it. See, that made a change to the actual object. Now we can't see it over here, but see it put the dot dot dots at the end of it. So that actually made the string longer by putting the dot dot dots at the end of the string. Okay, so Java does have a mutating string. What's funny is that the substring didn't mutate, but the append did. So you maybe maybe you can only grow the string. Maybe you can't shorten it. I don't remember exactly the details, but this thing mutated that string builder. Okay, so Java does have a way to let you mutate objects, mutate strings, but you have to use this special version of strings called string builders. Now, as in modern programming languages, it's getting to be more and more common to have more and more objects be immutable. Okay, that's become a very, very, very typical way to design new languages are designed this way. Okay, Java's kind of a medium language. It's not an old language. It's not a new language. It's not an old-fashioned language, but it's not an ultra-modern language either. Okay, like an example of an ultra-modern language you may have heard of if you pay attention, if you read about programming, is a language called Rust. And Rust is an example of a language that has a lot more things in it that are immutable. Another example is a language called Haskell. Has everything in Haskell is immutable, in fact. The language has everything being immutable. Okay, so immutable makes you have to think a little bit harder. You have to realize that sometimes when you call these methods, sometimes they give you back new objects, sometimes they can change the object. So for example, over here, that returned a new object, which we got lost, got garbage collected. That one didn't mutate. This one, no, it makes things kind of tricky. Like, why do some methods don't mutate and some methods do mutate? Now, string, they never mutate. Methods on strings never mutate. On string builder, it starts getting confusing. Some don't, if we visualize this, we see it compiles. So there's a substring method. And we go forward and we see that this substring did, if this substring had worked, this would be a lot shorter. It would just be HEL. It wouldn't be hello there. Okay, so sometimes methods mutate, sometimes methods don't mutate. Okay, and that can make things tricky to understand and tricky to read. Okay, but the modern trend is to make more and more methods not mutate. It's the modern trend is to make more and more methods. When you call a method, it'll do its work on a copy of the object and give you back a reference to the copy. Okay.
Why?
Do you have a question? Okay. Okay. So now let's look at some examples from Java that do mutate. Okay. In these books, they use a couple classes that are built into Java that are used for Java GUI programming. They're kind of nice to play around with. So I'm going to import two classes. Import these are both immutable classes, or I'm sorry, these are two examples of mutable class objects. You can see they have something to do with geometry, point and rectangle. Okay, they're actually methods that are used for doing GUI programming, graphics programming. Okay, so a point, I'll call it P1, new point. Point holds two pieces of data, an X coordinate and a Y coordinate. Okay, okay, and I'll make another point. Okay. Now, unfortunately, the Java visualizer doesn't visualize these guys very well. See, it just says you got a point object and another point object. It doesn't show us what's inside of them. Okay, so if we want to see what's inside of them, we need to print them. So I'll put a line of code. I'll go ahead and put a line of code in here that lets me print them. And it's just kind of annoying that the visualizer makes me have to print them to see what's in them. So this object, which is P1, that's this one here, it's got 2, 3 in it. And this one has got -1, 0, just like when I created now these are called constructors. This says, build me a new point object holding the data 2, 3. And this says, build me another point object holding the data -1, 0. Okay, right? Now, these are mutable objects, so I can do things like p1.x. Now this is a new thing. Notice that before we called methods on objects. Here we called methods on objects. Here I'm accessing the data directly in the object. I can just say p1.x. That's not a method. That's the variable, the data that's in the object. And I can set that equal to 100. Okay. And I can go to p2.y and set that to negative 25. Okay. And then if I want, I have to, now to see the changes, to see that these things mutated, I have to print them again. Okay, there's create the two objects, print them. They have what we told them to put in. Now mutate the object. Now the data in this, this box, this is actually a little box holding X and Y. And the X just changed in that box. This is a box holding another X, Y, and now I'm changing the Y that's in that box. But I have to print them to see that. So here I see that the X in P1 changed from 2 to 100, and I see that the Y in P2 changed from 0 to negative 25. Okay, so I can directly mutate these objects. And I'm actually mutating them just by actually accessing the data. I just go straight to the data. I can go straight to the X and put a value in it. I can go straight to the Y and put a value in it. Okay. Okay. Now, another example of something like this is rectangles. Okay. A rectangle in Java is, it holds more data than a point does. A rectangle, I'll call it R1 equals new rectangle. Rectangle holds 4 numbers. The first number is the X coordinate of its upper left-hand corner. The second number is the Y coordinate of its upper left-hand corner. The next number is the width of it. The next number is the height. Okay, I can draw a little picture of that. If I draw an X and a Y axis, okay, so this is a Y axis, and here's a X axis. Okay. Here's an X coordinate and a Y coordinate. Oops. Okay. So I've got a Y value there and an X value there. And then I can draw a rectangle with its upper left-hand corner at XY. Okay. So what I'm doing is I'm creating this rectangle, new rectangle, X, Y, width, height. Okay. And the width, of course, would be, the width would be from here. Yeah, that would be the width, and this would be the height. Okay, so that's how Java thinks about rectangles. Okay, you have holds 4 numbers, and they represent these 4 things. The location of the upper left-hand corner, the width of the rectangle and the height. Okay. Okay. So that's a picture of how Java thinks about a rectangle. So that's where it's, yeah. And then now when I create it, the Java visualizer again is going to not show me a picture of it. It's just going to write the word rectangle. So if I want to see it, I have to do that. And you can see X, Y, width, height. Okay, X, Y, width, height. And those are all mutable. So I could mutate the rectangle by saying something like, I can just say R1 dot height equals 5. But then if I want to see that mutation, I have to print it again. Okay, and here you can see that the height mutated. Okay, so I can't now. It'd be nice if the Java visualizer showed it to us over here. They show us the string objects. They didn't show us what's inside the string builder object, and they're not showing us what's inside the point or the rectangle objects. But the string builder, the point, and the rectangle are all actually mutable. So we should be seeing what's inside of them change, but we can only see the changes by printing them out. Okay, we're stuck with printing them to see that things got changed. Okay, now be careful about. Let me show you something you have to be careful about using words like mutation and changing. Okay, so let me work with P1 and P2. Okay, so P1 dot X equals 22. P1 dot Y equals 35. P2 equals new point 100, let's see, 1,000, 2,000. Okay. This is mutating, this isn't. So let me see what I mean by this is mutating. But I wouldn't say that this is not I would say this is not mutating. What do I mean by that? What's the difference between what I'm doing to P1 and what I'm doing to P2? I want to, let me add a code so I can see the results. Okay. What do I mean by this one's mutating and this one isn't? What does that line of code do? How do you think about that?
Think about it as it's changing the object rather than creating a new one, and then
Right. You think of this one as what you should do. Oh. You see that pop up by any chance?
Yep.
Huh?
I haven't had that yet.
Yeah, I got a pop up from McAfee asking me to buy something from them. You don't see it, do you?
Oh, I see it.
You do see it?
Yeah, we can see it.
So, yeah, okay. So Zoom actually showed it, huh? Zoom is real weird about what things it does show. I asked because I'm trying to figure out what Zoom is sometimes doing. Zoom is, let me show you something that I found out the other day. You can see this paint window, right? You see the paint window?
Yep.
What am I doing right now? Anybody got an answer? What am I doing? Do you see any change in your window? Any display?
Oh,
No.
Pardon me?
I see your paintings window in your browser.
No. This is the paint program. Okay, what do you see right now? You see the paint program, right? Sitting still.
Yeah,
What do you see now?
the same thing.
The same thing.
Nothing changed.
But you know what I'm doing right now is I'm moving that window all over. I'm dragging it left and right. Zoom doesn't show updates to Windows. Zoom, now, like right now, you see my window, right? Okay,
Yeah.
you see
Yeah,
it in the upper left-hand corner now, right?
Yeah.
yeah,
Okay. Now where do you see it?
lower right,
Did you see it move or did it just appear one place then the other place?
appear, and then the other place.
Yeah,
It's
see,
not moving at all.
Zoom is weird. Zoom, for example, that's one of the things I've realized. Like I was trying to teach a class where I was showing how programs behave differently when you resize their window. And it turns out Zoom hides all window resizing events from you. If I change a window, you don't see it changing, and then all of a sudden it just pops up differently. Okay.
Yeah.
Zoom is real funny about it's doing that to try to save bandwidth, but it's actually doing stuff that you as that you it actually kind of manipulates it manipulates what you're doing, what it's showing the other people without you knowing it necessarily. It kind of edits what you're doing on your desktop. Okay, so like certain pop-ups you don't see and certain pop-ups you do see. Oops, wait a minute. What happened here? Oh, it took me out of, I accidentally clicked on the stop sharing window. I accidentally clicked on the stop sharing button. Okay, so Zoom is kind of funny. It's very selective about what it chooses to show you about what you're doing with your desktop. Okay, now let's go back here. We were saying, how are you supposed to read this? You're supposed to read it as you reach inside of that object and make a change in it. So you're reaching inside the object and changing it. And you're reaching inside the object and changing it. So that's what we call mutating. But what does line 38 do? How are you supposed to think of that line?
It creates a new object,
Right. And what happens to the old object?
being garbage collected.
Yes. So this is actually garbage collecting the previous P2 and replacing it with another one. Now, it might look to you like it's just mutating P2, but again, you have to be very careful that this is not mutation. This is mutation. Now, down here, they'll look the same. If I go down here, I'll just see that, one thing that's kind of, I can actually add something to these printouts. Let me make it a little bit easier to read them. This way you kind of see a name for what's being printed out. This will make it actually a little bit easier to read the outputs. Okay, and here. here you can see that P1 changed from 103 to 2235. Okay, but that's what we mutated it. That means that this object actually is this object. They're actually the same object. But P2, see, P2 changed from -125 to this, but that's not the same object. It's a little bit hard to tell that, so you have to read the code to know that in the case of P2, this is a different object than this one here is actually a different object than what was there before. But this one is a mutation of the object that was there before. And many times when you're reading code, it really makes a difference. Are people mutating or are they replacing the object? Okay. More modern Java programming prefers replacing objects than mutating objects. But like you see, these things you can, and here you can do it either way. You could choose to mutate an object or you could choose to replace it. It's hard to, sometimes one is better than the other. Now this requires building a new object and garbage collecting an old object. So it would seem like this is better because all it did is it changed two numbers in an object, whereas this built a new object and garbage collected an old object. So that is more work than this. So you would think that this is better, and it is. Well, this is faster than this, but that doesn't mean better. Faster is not always better. This can sometimes be hard to understand. This can sometimes be easier to understand. As you learn more about programming, you'll see that there's reasons to have all these different choices. What's important now is to just start understanding that there are these choices. Later on, you'll start learning when do you make them. Like when do you choose to mutate? When do you choose to replace? Okay, but it's important now from our point of view is to start, it forces us to think about Java. So like on questions on a test, I can just ask you, which one of these is mutating? Which one of these is replacing? Or how does this code differ from that code? What does this do that's different than what this one does? Okay, so it's right now, it's a way of just getting you to think about what the Java language does. Later on, you'll see that this has advantages and disadvantages. This has advantages and disadvantages, and you'll start to choose whichever one suits you better for what you're doing. Now we're just trying to understand how these things work. Okay, all right. So again, we're talking about mutable and immutable, and actually mutable and immutable are two ideas, and then there's this replacing idea, which is neither a mutable or an immutable. It's not mutable, it's not mutating, it's replacing. And the textbook doesn't even really point that out, that there's mutation and there's immutable objects and mutable objects, and then there's this idea of replacing. When you have an immutable object, we saw it here, you mimic mutation with replacing. If you have an immutable object, you don't have any choice. You can't mutate it, but you can replace it. And that kind of mimics mutation. Okay. When you have when you do have a mutable object, you can choose to mutate it, or you could still choose to replace it. Okay. You can use replacing instead of mutation. Okay. So lots of ideas, lots of different ways to think about how Java is working. Almost all of this can be understood if you just draw good pictures. Okay. Now, the Java visualizer usually draws good pictures, but unfortunately, with some of these objects, we do lose the, we kind of lose the quality of the picture here. We just see string builder, point, rectangle, point. Okay, so we kind of lose some things here. Okay, all right. Now let's do another. Let's see what's inside of these things here. We can write, these were written for us by the Java people, but these are pretty simple. We can actually write our own version of these guys. So let's write our own version of point, and we'll see that lets us do something that's a little bit interesting. So what I'm going to do is I'm going to open up another visualizer tab. Okay. And I'm going to write my own class point. I'm going to define my own notion of what a point is. Instead of using the one that Java gave us, I'm going to start designing my own class. I'm going to design my own point objects. Okay, so I'm going to write my own class. Now, notice here that I have a class. I'll call it use my points. Okay, that's the class that holds the main method. Okay, that's the class that's going to be run. Down here, I'm defining a class that's going to describe what an object looks like. Okay, a point is going to be an int x and an int y. That's it. A point is two things, an int x and an int y. Okay, and I'm going to create my own point. Point p equals new point. Now, notice that that code looks a lot like what I wrote over here for points. But here, I'm using the point that I imported. So I'm using the point written by the Java people. Over here, I didn't import that. I'm starting to define my own point. Okay, this will visualize, and it runs. And what's kind of neat here is, oh, what happened here? I don't know if their machine hiccuped a little bit. Try it again. What am I? Did I misspell something? No. Let me put this. I'm curious. This doesn't. I don't understand. Let me put it into Java in Dr. Java. See if I get the same error. See, it compiled. Yeah, there's nothing wrong with it. And it'll run. Huh. What is going on in the Java visualizer? It was a hiccup in the Java visualizer. There's nothing wrong with that code. That's the first time I've seen the Java visualizer screw up like this. It doesn't like this line of code, but we know that there's nothing wrong with it. It compiles and runs. Let me do something really screwy. I don't know if it doesn't. Oh, I think I remember what. I think I remember now. Yes. I remember. Here's what it is. I remember. The Java visualizer has its own definition of point. That's not this version of point, and it's not. But so when I defined my own point like this, it collided with their version of point, and they gave me bizarre error messages. And it's every once in a while I run into this problem with the Java visualizer. For some weird reason, whoever wrote the Java visualizer, buried in their code somewhere is a point class. And that point class collides with the point class that you try to define here. So you get this weird error condition. And it's just got nothing to do with what we've done. It's that there is a somewhere in the Java visualizer, there is a point class that it doesn't collide with this one, but it does collide with one that we try to define. Okay. So if I change it, like if I just change the name a little bit, like, make it points instead of point, now it'll work. Okay. Now what's nice is notice that Java Visualizer is showing us what it looks like inside. Remember, it would not visualize these points, but it does visualize these points. Now I had to change the spelling a little bit to get it to work, but see how it showed me. Now watch, now I can see it mutate. Now I can go and do the mutation like p.x equal 4, p.y equals 5. Okay. Now I can see the mutation happen. Okay. P.x becomes 4, p.y becomes 5. Okay. Now another thing, now let me go back to the start. See, we're about to do line 5. See, these constructors look a little bit like functions, like method calls. If you go over here, see, these constructors look like method calls. You say new point and you give it parameters. New point and give it parameters. Now, my point, I can't give this parameters yet. I have to do something down here to give this parameters. So there are no parameters, but it's still like, it's something like a method call. So what the Java Visualizer does is it shows that you're jumping down here, creating the object, and then putting data in it. So you're jumping down here. That creates an initial data that's an initial point that's empty, and then it just returns. Now let me show you. I can change it a little bit. Suppose I want to initialize my x to be -1. So when you create a point, it starts off with -1 in both variables. Okay. Now watch what's going to happen. I come down here. I build a point object, but it's got zeros in it because those are the default values for x and y. So they get default values of 0 and 0. Then x is updated to -1, y is updated to -1, and now we return from the constructor back up to here, and now we let p point at that object with -1, -1 in it. Then we mutate it and mutate it again. Because this is what we're going to start to talk about. What goes on inside of code like this? What goes on inside of these constructors? What do you write in the file? There's a file called string builder. What do you write in the file called string builder to define these constructors and what goes in them? There's a file called point in the Java library. We're going to learn how to write these kinds of things. Now over here, I'm not writing a file called point. I'm just writing a class called point combined in the same file this one is. So what I have here is one file, but I have two classes in it. I have one file with two classes in it. One is public. This one is actually, see, this one doesn't have the word. If I put the word public in front of this, it won't compile. You cannot have two public classes. We'll see why that is later. What you really should be doing is putting this in its own file, but the Java Visualizer doesn't let me have two files. I could do that in Dr. Java. I could put this in a separate file. Now I would put the word public in front of this. Save it. Now I can go back over here, and this will work fine. Okay. It's actually running. What it is this file is using the point that's defined in this file. Now, so this is now this is a public class in its own file, and this is a public class in its own file. The Java Visualizer doesn't let me do that. The Java Visualizer doesn't let me have two files. So I put two classes in one file, but only one of them is public. The one with main has to be public. This one, it's kind of like it's private, but I don't think they let you put the word private there. Yeah, see, they don't let you write the word private there. And we'll see that, but it's essentially, it's acting as a private class. It's a class that only belongs to this file here. Only this main method can use that point class. Over here, this point class can be used by any program I write. Okay, this has been public, and now it can be shared with other programs. And we'll add things to it to make it more interesting. But right now, I have my own point class that I can write programs that make use of it. Okay, in the Java Visualizer, I have to combine them into one, essentially combine them into one file, like they were earlier when this part here was inside that file there. Okay, now what else can I do here? Over here, I have a constructor that lets me say what to initialize the point to be. Over here, if I want to do that, I have to write something that looks like a method. I write public point. So you know, this is the points. The name of this is the name of the class. I say public points. I say int init. Let's see. X value, int y value. Okay. And then what I'm going to do is I'm going to use these values to set these variables. So I'm going to say the X in my point is got X value, and the Y in my point gets Y value. Now this lets somebody decide what to put into the point. Now actually the -1 here are kind of pointless. I'll leave them there, but you'll see that what happens is the point's going to initially be 0, then it's going to be changed to -1, -1, then it's going to be changed to X value and Y value. So this is really kind of, right now it's not written very well. Okay. Now down here, I could now say something like point P2 or points P2 equals new points. But now I can say, oh, I want this to be at 2245. Okay. Now, Java complained that I don't have, see, notice that before I had this, and that was fine. But now I've defined this. So that means that Java says I have to add another one that does no arguments. I have to write, now I have to write it myself. So I have to do this. I have to write this one that takes no arguments. And I'm just going to say, and I'm not going to do anything. I'm going to leave it -1, -1. Notice that now this, see how that compiled, even though I didn't do anything in that. I didn't do anything inside there. as soon as I define one constructor, I have to define this what's called empty constructor, or this empty constructor. If I don't define this one, I don't have to define this one. But if I do define this one, I have to define this one. Java's kind of messy about some of this stuff. And let's just watch what this thing does. Okay. I'm going to create a point using this one. So I go down here. The point's initialized to 0, 0, because 0 is the default value for an int. Then it gets -1 and gets -1 because I put -1, -1 in it there. Notice that this thing jumped up to there. Very strange code. Notice how I jumped from here to here and here. And now I'm back to here. That's really weird. Okay. And now I'm about to return from the constructor. And now I've got a point with -1, -1 in it. I update those. Now I'm going to create a constructor with 2245 in it. Now watch what happens. I go down here. I get this constructor. I start with a point with 0, 0 in it because the default value for int is 0 and the default value for int is 0. Then I go up here and change them to -1, -1. Then I change them to X value and Y value. Okay. And then I'm done. So now I'm going to return and create a new point. Okay. So what our goal for our Thursday is to start learning the rules of these. Now, right now, these are written badly. I've kind of purposely wrote this badly to kind of show you how weird Java can be. But we're going to learn the rules for defining our own classes so that we can build our own objects. Okay. And we can put anything in the objects we want. Like if I wanted to, I could give these points names. Like if I wanted to, I could say, oh, every point deserves to have a name. That's a string. Okay. So I could go ahead and do that. I could just give points names. Why would you want to give a name to a point? Call it Bob or Jane. But if I want to have points with names, I can just go ahead and do that. I can put a name, what we call a name field, in my point objects. Okay. So if I think that's useful for some reason, I can give my points a name. Okay. So we'll see how we can design our own classes and then build our own objects. Like right now, see, my names are just blank. So I have points with names, but the names, I didn't put anything in them. So the name is null. It doesn't point to any string. But my points potentially, I can give one of those points the name Bob, and I can give one of them the name Jane if I wanted to. Okay, so that's what we're going to start doing in the reading. That would be these two sections here. We started talking about what's in these sections: anatomy of a class, designing classes. So that's where we'll pick up on Thursday. Continue talking about this, and also there's going to be, hopefully by Thursday, there's going to be one last programming assignment that'll be due on at the last day of class. So there's going to be one more programming assignment, and it'll be due at the end of the semester, which we're getting pretty close to. Okay, and so we'll quit there, and on Thursday we'll start talking about what it means to design our own classes. What is in a class, and how do we design our own classes? How do we put things in classes? Okay, so if you have questions over any of these examples, please write, and we'll do these sections on Thursday. Okay, so we've run out of time. So if you have questions, please write to me, and see you again on Thursday. Bye.